What if I told you that everything you know, every star in the sky, every galaxy we can see, even time itself, is doomed to vanish? Not tomorrow, not in a million years, but inevitably. The universe has a destiny written into its very fabric, and it is far more dramatic, far more terrifying, and far more awe-inspiring than you could ever imagine. Tonight, we're not just looking at the future of Earth or the death of the sun. We're taking a journey to the ultimate end of everything. Stay with me, because once you see how it all ends, you'll never look at the night sky the same way again. Before we dive in, make sure to subscribe and turn on notifications, because this isn't just another video, it's a journey through time itself, and you don't want to miss what comes next. Let's begin. What does our future hold? It's a question as old as thought itself, a question that has haunted philosophers, poets, and scientists for centuries. Every culture has tried to imagine the end of things, but only in recent generations has science given us the power to look ahead with clarity. We cannot predict every detail, yet physics, astronomy, and cosmology allow us to trace the great outlines of what is to come. And what we see is astonishing. This is not a story measured in years or centuries. It is a journey through unimaginable stretches of time, epochs so vast that human history is little more than a flicker in the dark. Together, we will travel all the way to the end of time itself, following the universe as it transforms, evolves, and ultimately fades. But before we leap into the distant future, we begin close to home. The geological age we live in has already shifted. Human activity, industry, technology, the reshaping of landscapes has pushed the Earth into a new epoch, the Anthropocene. For the first time, a single species has become a planetary force. The climate warms, seas rise, ecosystems crumble, and extinctions spread. These are changes that unfold in mere decades, yet their echoes will ripple across thousands of years. What humanity does now will decide the conditions of the planet for millennia to come. And yet, even these monumental transformations are but the prelude. The planet's fate is tied to the far greater drama of the sun. In roughly 5 to 6 billion years, our star will begin to exhaust the hydrogen in its core. Its delicate balance between gravity and nuclear fire will falter, and the sun will swell into a red giant, a vast, bloated titan in the sky. Its surface will stretch outward until it engulfs Mercury, then Venus, and perhaps even Earth itself. Any world that escapes consumption will still face devastation, scorched by the sun's fierce expansion. The solar system as we know it will be unrecognizable. After this violent transformation, the sun will shed its outer layers, casting them into space as a glowing planetary nebula. What remains will be its core, a white dwarf. This shrunken, dense ember will be no larger than Earth, yet will contain half the sun's original mass. For a time, it will shine with ghostly brilliance, as bright in our skies as the full moon once was. But slowly, inevitably, it will cool. And here is the cruel truth. Time works against all stars. After spans far longer than the universe has yet existed, white dwarfs will cool until they emit no light at all. These corpses are called black dwarfs, theoretical objects so cold and so dim that they are invisible in the dark. None exist today, for the cosmos is still too young. But given enough time, they will dominate the remnants of stellar evolution. One by one, the stars will burn out. Galaxies will grow quiet. Without the raw material for star birth, the night sky will lose its sparkle. What remains will be stellar remnants, white dwarfs, neutron stars, and black holes drifting in ever-widening voids. Gravity will continue its relentless work, flinging stars into intergalactic space, pulling planets into their suns, feeding stray matter into the hungry mouths of black holes. Every so often, a dramatic collision will flare, a pair of neutron stars colliding, or a rogue brown dwarf sparking a new temporary sun. But these are fleeting bursts in a deepening night. This leads us into the degenerate era, an age where the universe is no longer powered by young stars, but by the cold remnants of what once was. Brown dwarfs, the failed stars, might collide and briefly ignite. Neutron star mergers will send out titanic blasts of energy. But the overall trend is toward silence, toward cooling, toward stillness. White dwarfs dim to black dwarfs. Black holes grow as they consume what remains. The universe is entering a time of shadows, and then comes the black hole era. For decades, black holes were thought eternal, perfect prisons from which nothing could escape. But quantum physics has revealed a different story. Through a process called Hawking radiation, black holes very slowly lose energy. Virtual particles appear at the edges of their event horizons. One falls in, the other escapes, and to the outside world it looks as if the black hole is leaking. Over trillions upon trillions of years, this tiny effect adds up. Stellar black holes fade. Supermassive black holes at the centers of galaxies take even longer, but in the end, they too will evaporate. And when the final black hole disappears, the last great structures of the universe will vanish with it. What follows is the slowest, quietest chapter of all, the heat death. A cosmos in which thermodynamic free energy is gone, where entropy, disorder, has reached its maximum. Without energy differences, no work can be done, no stars can shine, no galaxies can form, no life can endure. The universe drifts into equilibrium, a vast frozen plain where nothing ever truly happens again, not with a bang, not even with a whimper, but with silence. As the last stars burn out and galaxies dim into obscurity, the universe falls under the reign of its most mysterious rulers. Black holes. From stellar mass remnants left behind by dying suns to the supermassive giants anchoring galactic cores, these cosmic monsters become the final strongholds of structure in an otherwise thinning, cooling cosmos. For much of history, astronomers believed these titans might endure forever, eternal prisons from which not even light could escape. But quantum theory revealed a hidden truth. Space, it turns out, is not empty. It seethes with invisible energy, spawning fleeting pairs of virtual particles that appear and vanish in the blink of a quantum eye. Near the event horizon of a black hole, these pairs behave differently. One particle may tumble inward while its twin slips free. To a distant observer, it appears as though the black hole itself is glowing, bleeding energy into the void. This faint whisper of energy is called Hawking radiation. It is the slow undoing of immortality. For smaller black holes, the process is relatively fast, ending them within inconceivable but measurable spans of time. For the giants, those billions of times more massive than our sun, evaporation takes longer than the current age of the universe multiplied by countless trillions. Yet even they cannot escape forever. The larger the black hole, the slower the leak. But the end always comes. When that end arrives, the death of a black hole is anything but silent. As its final mass is radiated away, it unleashes a tremendous burst of energy, the last fireworks in a universe that has forgotten the light of stars. One by one, these dark engines vanish. And with the last supermassive black hole's explosion, the cosmos loses its final great structures. No planets, no stars, no remnants, only a faint haze of particles, photons stretched to exhaustion by the ever-accelerating expansion of space. But even here, the story refuses to end. Some theories suggest that the building blocks of matter themselves, protons, may not be truly stable. If protons eventually decay, then even the stubborn remnants of creation will not endure. Black dwarfs, neutron stars, degenerate matter, all will slowly dissolve into a thin wash of radiation. The universe would not simply be dark and empty. It would be stripped of matter entirely, leaving only energy scattered like ashes in an endless night. Meanwhile, the stage upon which all this unfolds, space-time itself, is changing. Observations of distant galaxies reveal that the universe's expansion is not slowing down. It is speeding up. Something unknown, something unseen, is driving this acceleration. We call it dark energy. Dark energy behaves unlike anything else in nature. Matter grows thin as it spreads out. Radiation weakens as it dilutes. But dark energy seems constant, a pressure embedded in space itself. Right now, it makes up about 70% of the entire universe's energy content. And yet, no one knows what it truly is. Its future determines ours. If dark energy remains steady, galaxies will continue to drift apart until, from any one vantage point, the universe beyond becomes invisible. Stars, then galaxies, then entire clusters will vanish over the horizon, receding faster than light itself can travel. In such a cosmos, heat death becomes inevitable, endless expansion, infinite darkness, and a frozen eternity. But the universe may hold other fates. If dark energy grows stronger, its repulsive force could one day tear apart galaxies, suns, planets, and even atoms themselves. A cataclysm known as the Big Rip. If dark energy weakens or reverses, gravity may reclaim dominance, pulling all matter back together in a cosmic collapse, the fiery end of the Big Crunch. And there are theories of cycles, universes that expand and contract endlessly, reborn in perpetual rhythm. Which destiny awaits depends on the true nature of dark energy, a mystery still locked away from us, one of the deepest puzzles in modern science. Yet even these grand finales might not be the final word. Some physicists suggest that our universe may be just one bubble adrift in a far larger multiverse. In this vision, countless universes emerge, collide, or vanish, each governed by its own unique rules. Some may harbor life, others may collapse in an instant. Still others could be stranger than anything we can imagine. And if advanced civilizations can survive long enough, they might not be bound by this ending at all. With unimaginable technology, they could trigger the birth of a new cosmos, a baby universe, disconnected from our own. A lifeboat to carry intelligence across the sea of eternity. If such escapes are possible, then universes with life would not simply vanish, they would reproduce. The multiverse itself might be shaped by survival, its landscapes seeded by the children of intelligent beings who refuse to surrender to entropy. It is speculation, yes, but it forces a profound question. Does every ending carry within it the seed of a beginning? What we do know is this: the universe as we see it today, alive with galaxies, blazing with starlight, and sheltering life on a pale blue planet, is only a brief and fragile moment. On cosmic scales, existence as we know it is a flickering spark, suspended between the violent birth of everything and the cold inevitability of forever. At last, after quadrillions upon quadrillions of years, the universe witnesses its final spectacle. The last supermassive black hole, a colossus that has endured longer than all the galaxies combined, reaches the end of its life. For a fleeting heartbeat of cosmic time, it erupts in a blinding flash, a final act of defiance against the encroaching night. That flash is brighter than entire galaxies, yet it lasts only an instant. The glow fades, and with it, the universe falls into absolute darkness. What remains is not stars, nor planets, nor even the silent hulks of collapsed suns. All that lingers is a ghostly mist, photons stretched to almost infinite wavelengths, drifting endlessly across the void. This radiation, thinned to near nothingness, is the last breath of a cosmos that once burned with fire. Here begins the longest and quietest chapter of all. Physicists call it the heat death. It is not a death by fire, but a death by exhaustion. The loss of all usable energy, the extinguishing of every gradient that makes motion, structure, and life possible. Entropy, the great measure of disorder, has climbed to its peak. The universe has reached maximum chaos, and paradoxically, maximum stillness. No heat flows, no stars form, no galaxies collide, nothing changes. Without energy to drive processes, existence itself loses rhythm. Even the arrow of time bends toward irrelevance, for time is nothing more than the record of change. And here, there is no change left to measure. Yet the silence may not be absolute. If protons are unstable, then even the smallest fragments of matter will not survive this era. Slowly, imperceptibly, they will decay into radiation, until not a single atom remains. If protons endure, a handful of stubborn relics, black dwarfs, neutron stars, may drift in the dark. But even these, through the slow leakage of quantum processes, will eventually unravel. Whether it takes unimaginable eons or something. Longer still, the end is the same, a frozen, featureless stillness. Some scientists and philosophers have called this the moment when time becomes meaningless. Without change, without events, one instant is indistinguishable from the next. The universe simply is. A vast, unchanging sea, colder than thought, quieter than silence itself. It may sound like despair, but in another light, it is a reminder of how extraordinary the present truly is. For in all of cosmic history, there is only a brief and dazzling window where stars ignite, galaxies blaze, and planets cradle life. On the immense timeline stretching from the Big Bang to the end of all things, human existence occupies less than the blink of an eye. And yet here we are, alive, conscious, aware of it all, a flicker of light against eternity. And perhaps even this is not the end. Some theorists whisper of quantum fluctuations, chance tremors in the void that could ignite new universes. Others imagine civilizations so advanced that they escape entropy by crafting lifeboats. New realms of space-time seeded before the great silence claims everything. In such visions, every ending conceals a beginning, and the death of one universe becomes the birth cry of another. But if no such escape exists, if the silence is final, then the fate of our cosmos is sealed. No stars, no galaxies, no echoes of what once was, not even time itself, only the endless stillness of forever. And so, after uncountable ages, the universe falls silent. No more stars, no more galaxies, no more time, only the endless stillness of forever. But in that silence lies a question. If everything ends, what will you do with the fleeting spark you've been given now? If this journey moved you, don't let it stop here. Subscribe to the channel, share this story, and leave your thoughts below. Because every conversation we have about the universe is another spark of light against the dark. Together, let's keep exploring the mysteries that make our tiny moment so extraordinary.